Alright, so this is the most difficult type of problem that we're going to do. It's because it's quadratic. Because the ball lands at a position that is different from where it was launched, there's not that symmetry. Alright? Now, this asks us to find the maximum height, the horizontal distance, and the total time. There's a lot of stuff to complete, so I'm going to do this in 3 different videos. I think the thing that is going to help me out the most for this problem is the times. Okay, so I know if I want to figure out the total horizontal distance, I'm going to need to know the total time is traveling horizontally. All right, so I'm going to go that route. I'm going to work backwards. I'm going to first find the total time, then I'm going to find the horizontal distance, then I'm going to find the maximum height last, because it's not really related to these two. Okay, so I have to look in the y direction. It doesn't matter which side you look at first. You can look at the x first. Okay, so we know it's being launched at an angle. Most important part. I want to figure out the x and y velocities. Okay, so the x component is going to be 25 meters per second times the cosine of 53, and that the y component is going to be 25 meters per second times the sine of 53. Okay, got to use the calculator. 25 cosine 53. I get 15. 25 sine 53. I get approximately 20. I'm going to round it up to 20. All right. So I'm going to find the total time first. If I try to find it in the x direction, I need to know the total horizontal distance. So clearly I cannot find it in the x. So I'm going to have to find time in the y direction. I know I have my initial y. I know that this is accelerating under gravity. And the only other thing I know, there's no symmetry, is the height at which it was launched. So I know that if the cannonball starts here and ends here, it has a vertical displacement of -60. Again, if we make this 0 meters and that part 60 meters, final minus initial, gives me a -60 meters. That's a very important piece right there. So if we identify the equation here, and just block that off, we would pick that delta y is equal to v naught t plus 1/2 at squared. Now, this has basically been the equation for the last 2 problems that we've completed. The only difference here is we don't have a 0. So since we don't have a 0, this is quadratic. So I have to rewrite this in quadratic form. All right. So generic quadratic form is ax squared plus bx plus c equals 0. And then we have a formula that solves for x. Well, what we're looking for here is t, so we have the squared term of t, the non-squared term of t, and the one without the variable has to be equal to 0. Okay? So this is what happens now. We compare this to ax squared plus bx plus c equals 0, so that 1/2 a stands for a, v naught stands for b, and plus negative delta y is what c is. So if we use our quadratic formula as x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2 times a, and that's generic form. That should be matching up with this. And we make it specific for what we have. Okay? So generic form is x, specific form is t. So t is going to equal negative b. What is our b? Our b is v naught. Plus or minus the square root. B is still v naught. V naught squared. Okay, this is going to get a little messy here. Minus 4. What is our a? Our a is 1/2 of the acceleration. Times c, which what is our c? Our c is negative delta y. All over 2 times what our a is, 1/2 a. Okay, so this will simplify down a little bit. You can see that everything kind of stayed the same up until here. So we have this and this cancel out to be positive. You have this 4 canceling out that 2. So we end up with that inside the parentheses. This is all over a. So this is our solution for the quadratic equation to solve for the time. It's a little complicated. You might have to watch that video a few times to see what we really did. In another video, I'll show you how to get around using the quadratic. All right? But now that we have it in this form, we just have to do the calculations. Okay? So time is going to be equal to negative v naught. So it's negative 20 meters per second. I'm not going to write the units. Plus or minus whatever is underneath this square root. Okay? So I recommend getting it down to this step. So I'm just going to use the calculator and figure out what would be underneath that square root. So the square root of v naught squared, which is 20 squared, plus 2 times negative 9.8 times negative 60. So it's very important to have all those negatives in there correct. All right. If we hit enter, we see that we get 39.7. Okay. Now, if we work through those units, we would get meters per second here. And then we have to divide by negative 9.8 meters per second squared, because that's our acceleration. So we'll end up with meters per second. Sorry, I didn't move the paper. Meters per second over meters per second squared, which turns into seconds. Okay. So this 39.7 was what I just plugged into the calculator for whatever's in this parenthesis right here. So you have 20 plus and minus 39.7 divided by negative 9.8. Okay. Now you can get you're going to get 2 answers for time here. You're only going to get one that is correct. If you reason it out, the negative time, well, negative times don't exist, so the negative time will be the incorrect one. So if I add negative 20 plus 39.7, I'm going to get a positive number on top. Okay, it's going to be like 19.7. So a positive number divided by a negative number gives me a negative number. So the addition here is not going to give me a time that exists. So if I just use the negatives and I do negative 20 minus 39.7 divided by negative 9.8, I get a positive time equal to 6.1 seconds. And that is the total time that the object is traveling in the air. On the next video, I'll show you how to get around all these steps right here and just think about it in another, slightly different way.